So this is where we left off. We actually did this page yesterday, but I just want to go back because the next couple have the same instructions. Find the zeros and their multiplicity. Determine if the graph crosses or touches at each. Determine the maximum number of extrema, and sketch. So that's what we're doing on these. We did this one yesterday, so we're going to go on to this one. Okay, so what are my zeros? 5 and -4. I don't have a 0 at 0 because that's just a 2 in front. So I have 5 and -4 are my zeros. What's the multiplicity at 5? 3. So this one has the multiplicity of 3. What's the multiplicity at -4? At 2. Okay. Does it touch or cross at 5? It crosses. If it's odd multiplicity, it crosses. So it crosses at 5. And at -4, does it cross or touch? Touches. And then what is my maximum number of extrema? What's my max number of extrema? 4. Because what's my degree? It's 5. I add up all my exponents. It's 1 less than my degree. Add up all the exponents. That's what it's going to be. Add it up. Here we go. It's 1 less for the maximum number of extremas. So I have 4. Okay. What is my degree on this one? It's 5. Is my first coefficient positive or negative? It's going to be positive. And here's what you can do to figure that out. You take whatever this first term is to that power, take whatever this first term is to that power, and to multiply what you get for those times anything that's out in front, and that will tell you your first term. You won't know anything else, but you will know the first term. So if I take x squared, I get x squared for this one. Take x and cube it, I get x cubed for this one. X squared times x cubed is x to the 5th, and then a 2. So my first term on my polynomial is 2x to the 5th, which means that it looks like 2x to the 5th, 2x to the 5th, with squiggly stuff in the middle. Okay, you can find your first term. Remember, that's the end behavior. That's what it looks like from the outside with squiggly stuff in the middle. Take the first term and take the first thing in each one of those parentheses, take it to that power, multiply it times anything in front. That gives you the first term of your polynomial. And that tells you what it looks like, big picture. So it looks like x to the 5th, which looks like this, with squiggly crap in the middle. Okay.
What was that your thoughts about the exponential because of this one?
If the first term is positive, if the exponent's positive, then it's going to have a U-basic shape with squiggly stuff in the middle. If the first term has if your degree is odd, if the power is odd, it's going to look like this or look like this. It looks like this if the first term is positive. It looks like this if your first term is negative. Okay. Positive, negative, positive, negative. Okay. So I have -4 and 5. -4 and 5, and I've determined that the first one is positive, so it's going to come up, touch at -4, go down, and then come up across at 5. So I know it's going to do this, and then who knows what's there, and then that. And I know that's at least going to look like that. That's the best I can do at this time. There might be more crap going on in between. We do not yet possess the ability to tell what that is. There's squiggly stuff in the middle. I have no idea what that squiggly stuff is with the knowledge that we have at this time. Okay, you will gain the knowledge at some point to figure out that squiggly stuff in more detail. We just can't figure it out right now with the knowledge that you have. I know the hump, I know where it touches, I know where it crosses. In between here, God only knows what's going on. Okay. Because I have an odd power, it crosses. If I have an odd multiplicity, it crosses. If I have an even multiplicity, it touches. That's it. And I know the basic shape, it comes up to 4 and touches. Well, I know it's going to come up to 4 and then go right back down from there, and then come up through 5s. Nowhere else is it going to touch or cross, so I know I'm done with that. Okay. Give this one a try. All right. So if we are working the problem from left to right, what is our first 0? 0, because we have the x by itself out in the front. What is the multiplicity of that 0? 1. It has a multiplicity of 1. So which, does it cross or touch? It crosses. Okay. Our next 0, working across the line, is what? -1/2. Set 2x plus 1 equal to 0, you get -1/2. What is the multiplicity of that one? 1. So does it cross or touch? It crosses. And then working my way down, what's the next 0? 3. What's its multiplicity? 2, because it's squared. Does it cross or touch? It touches. Okay. What is the degree of my polynomial? 4. Add up the multiplicities, you get your degree. It's degree 4. Because I have x to the first, 2x plus 1 to the first, x minus 3 squared. So I have a degree 4. So my degree is 4. So how many max and mins do I have possible? 3 possible extremes. 3 possible or maximum extremes. Okay. What is my first term? -2x to the 4th power. Because I square this term because I have squared, so I have x squared times 2x times -x, -2x to the 4th. So -2x to the 4th is my first term. -2x to the 4th is my first term. So that means x to the 4th. Negative means it opens down. It's an even power, so both sides open down. So it's going to come up, do squiggly stuff, and then go back down again. That's what the -2x to the 4th tells us. So I know at 1, it crosses. At -1/2, it crosses. And at 2, it touches. Well, if at 2 it touches and it has to come down this way, it has to go, what? Sorry, 3 it touches. My bad. My bad, 3. What did I do? I'm sorry, I looked at the wrong column. I looked at the wrong row of numbers. My bad, thank you. So 0, -1/2, and 3. Now, at 3 it touches. And because it comes down this way, that means at 3 it has to do this. It crosses here, crosses there. It has to come up and cross. So it goes up, comes down, goes up and touches, and comes down. And it looks something like that. I do not know the exactness of my bubbles in the middle, but that's what I got going on.
How did you figure out that it's
My first term is negative. And because it's to the 4th power, that means it's a U shape either going up or down. The negative means it goes down. Like I said, the ends look like this with squiggly stuff in the middle. Okay. Questions on this? Okay. Now, these are polynomials. in factored form. They're not, strictly speaking, polynomials. They're factored forms of polynomial equations. We need to actually find the polynomials. It's not that hard when you're given the information you're given. Find a polynomial of degree 3 whose zeros are -3, 2, and 5. -3, 2, and 5 means that I have factors of x plus 3, x minus 2, and x minus 5. These ones here mean I have x plus 3, x minus 2, x minus 5. Degree 3, is that degree 3? Yeah, so I don't have to worry about anything else. What do I have to do from here on out? I got to FOIL. Oh, FOILing's easy, at least the first step is. So if I do these ones here, I get x squared plus x minus 6. Multiply the first two terms. Add, when I have just x in the front, this is really easy because it's x squared. Add the two numbers, multiply the two numbers. I mean, really, that's it. Add the two numbers, multiply the two numbers. Middle term is adding them, last term is multiplying them. If you have x in front, that's all you have to do. And then times x minus 5. Okay, this is where the fun starts. Now, I never had any of you for Algebra 2. I would have shown you this in Algebra 2. But whenever I have something like this, I set that up. This is how I multiply polynomials that are more than just two terms each. Two terms each, you FOIL. Anything else, this is what I do. And I've done polynomials that are 6 things times 5 things. And you set it up like this. You set up a box. I have a 3 by 2 because I have 3 terms and 2 terms. If I had 3 terms and 4 terms, I'd have a 3 by 4 box. And this is what you do. You take these terms that are in 3-1, write them on top. X squared, x, negative 6. Take the other one, which is a binomial. Write those 2 terms down the side. X and minus 5. And then you fill in the boxes like a multiplication chart. X times x squared is x cubed. X times x is x squared. X times negative 6, negative 6x. Negative 5 times x squared, negative 5x squared. Negative 5 times x, negative 5x. Negative 5 times negative 6 is 30. And here's what's really cool. If you have like terms, they're on the diagonals. So I have x cubed. And then these two are like terms. Negative 5x squared, 1x squared, negative 4x squared. These are like terms here. Negative 6x, negative 5x, negative 11x, and then plus 30. Okay. And I've done this, literally, I've done this with a 5-term polynomial times a 6-term polynomial. Set up a great big grid on a piece of paper. You fill it in like multiplication, and then across the diagonals are like terms. And you may have like 10 like terms, but they're all on the diagonal, so it's really easy to keep track of what you're doing. I like this because it's very organized, very easy to keep track of what you're doing. If you have another method that will get you the correct answer, I'm okay with that. But I like this because it keeps things organized. And organized when you're doing something like this is probably the most important. Okay. Next one, same idea. Find a polynomial such that negative 2 is a solution with a multiplicity of 2. The negative 2 means that I am going to have x plus 2 as a factor. And the multiplicity of 2 means that that is going to be squared. And then 4 is a solution. So I have x minus 4 with a multiplicity of 1. So I technically have a first power there, but we don't write first powers because we're lazy. You know, that's why mathematicians don't put 1s in front of things that are by themselves, because it's redundant and we're lazy. We don't put 1 in front of x, because how many x's do we have? We have 1 of them. If we have anything else, we'll put the number in front, but if we have 1 of them, I don't need to put 1 in front. That's redundant. And we're lazy. We don't write things that we don't need to write to be clear and concise. That's why you have in geometry SSS instead of sine, angle, sine, or sine, sine, sine. All the shorthand things that you have. Okay, what do I need to do? Boil it out and multiply it. Okay. X squared plus 4x plus 4 times x minus 4. And then, like I said, you can set up its grid, or if you wanted to, this is one that's fairly easy to distribute, but I like setting up a grid. Things cancel out on this, it's kind of nice. It works out well that way. I do like using the box. I do. It works for me. X squared, 4x, 4x minus 4, and you just fill in the blanks. So I get x cubed, 4x squared, 4x, negative 4x squared, negative 16x, negative 16. And so the nice thing is here, I get x cubed, my x squareds cancel each other out. I get negative 12x minus 16. So once again, I don't care how you multiply it together, just get it multiplied together. As long as it's good. You've been doing this long enough, hopefully you've got methods that work. Like I said, that's my favorite one when I have big stuff. Okay, number 5. Find a degree, polynomial degree 4 with zeros of 1, 2, and negative 2. So that means I have x minus 1, x minus 2, x plus 2. And then what? No, because that would give me a 0 of what? 0. If I put an x in front, that means I have another 0 at 0. Those are my only zeros I have. What was that? Yeah, because it's not specific, is it? So technically, how many answers could I have? Technically, there's 3 answers that are available to you. Technically. Because it doesn't specify which one has a multiplicity. The whole thing is a degree 4, but I only have 3 zeros, but degree 4, one of those zeros has to have a multiplicity of 2. So one of those needs to be squared. Does it specify which one? No. If this was a test question, how many answers, how many solutions would I have to have available to check your work? I'd have to have 3 solutions because there are 3 possibilities. Okay. Now, I'm all for doing things the easy way. I am all for doing things the easy way. So if I'm doing this one, I'm making the first one a multiplicity of 2. And you'll see why. If I make this one a multiplicity of 2, that means this one is x squared minus 2x plus 1, and these two multiplied together is x squared minus 4. And if I had squared one of the other ones, I'd have some extra term in there that would really make it a little. I'd have 2 with 3 terms each, rather than 2 with 2 terms. Think smarter, not harder. If I were one doing it on a test, man, I'd do this one because you got one less term to worry about screwing up. Okay. And then you x squared negative 4, x squared minus 2x plus 1. So I have x to the 4th minus 2x cubed, and then x squared there minus 4x squared, 8x minus 4. Now, because I don't have every term of the polynomial, my diagonals are not where my like terms are on this one. They're not that way because I go skip from x squared to negative 4 with no x between them. The only way the diagonals line up is if I have every term of the polynomial in there. However, it's still easy to figure out where my like terms are. These are my only two like terms. And they're almost diagonally. They do kind of line up a little bit. You can see that. But those are my only two like terms. So I have x to the 4th minus 2x cubed minus 3x squared plus 8x minus 4. So once again, there are two other answers. I'm not going to work them out. That's up to you. Okay? Question.